Hello guys, how you doing? How are my ROS developers, ROS developers, my favorite ROS developers of the world? How are you doing, guys? I am here having my white label coffee, white label. Do you get it? Yeah. Okay, very bad joke. Yes, I know. So are you ready for the second class that we are going to do about ROS controllers? Are you excited about that? This is the second one. We are going to learn a lot about ROS controllers and ROS control package specifically. And today is very special because it's going to be our first live class that we are going to do by using C++. So I hope that you have had some heavy lunch or some breakfast. It depends on what time of the day is for you, because we are going to stress a little bit more than previous days today. But don't worry, I'm going to explain to you step by step, okay? So I would like to go to the chat quickly now and say hello to all the people that is there. I see that people are still coming, that we are about to start, so please come in. Go to the back of the room and let me say hello to Sam. Hello, Sam. Daniel Jewish. Hello, Haro Stanko. Hello, how you doing? Marcus, Rothes, and Danny Dask, all of them saying that they are ready. I hope that all of you are also ready. And how are we going to proceed here today? Well, as always, but let me explain for the new people that comes, okay? Every week we have some people that comes new and they don't know how does these live classes work. So what we are going to do is I have prepared what we call a ROSject, okay, for this live class. A ROSject is a package that contains ROS code, contains gazebo simulations, and contains very detailed notebooks with the instructions and all the material for the class that we are going to do today. And this is included inside the ROSject. So what I'm going to do is to share this ROSject with you so you can open it right now there at the live, during the live class. You can open it and then follow on the screen my instructions and do the same as I am doing at the same time, okay? So all of you are going to be practicing with me and with all the other attendants there in the chat that are here on the room. They will be also practicing at the same time. And this is possible because we are using the ROS Development Studio, which is an online tool for programming robots with ROS. And the good thing is that you don't need to do anything. It's just a web browser address that you can visit. And then, well, actually, when you open the ROSject, it will automatically lead you, bring you to the ROS Development Studio and open it, everything in there, okay? So you're going to see that it's quite simple. How am I going to share the ROSject with you? Well, so, the ROSject is shared by a link. So I'm going to post this link inside there in the chat. Then you only have to press this and on that link, and then it will guide you to the steps to get all the ROSject. One final thing, remember that everything that we do here on the ROS Development Studio, you can do it the same way in your local computer. Okay, so yeah, so it depends if your local computer has a proper installation of ROS. But what we are trying to avoid you is to do this kind of installation in your local computer by using the ROS Development Studio. It's a lot faster, it's a lot more dynamic. As you can see here, you can share and it will work to anybody. Okay, so nothing more. Let me see if there are any more questions. Oh, yeah, so, okay, yeah, just updated this. Here I see Ahmed, hello, Ahmed, use, Kemal, Sam again, okay, Ahmed, then Sandra, hello, Mechatronics, Abraham, Bikas, Bamani, and another Mohammed, that is a different one. It's Tahir from Egypt, and Ahmed, Ahmed, sorry, I pronounced it wrongly. Yeah, sorry, Ahmed. I meant Ahmed and Mohammed, sorry. And then Adam Krasik, hello. And then Ritesh and Sri, he's the latest one. I didn't hear. I'm so happy. Let's start because we have a lot of work to do today. We are going to sweat a lot in order to make this work, but it's going to be very, very satisfying, and you are going to learn a lot about ROS. So let's go straight. Let me share with you my screen so you can see where is my ROSject, the one that I have prepared for you, and how I am sharing this with you. Okay, just a second. I'm going to connect to my screen so you can see. Here it is. Too many windows open as always. Okay, there it is. So you should be seeing my screen of the ROS Development Studio. Sorry, needed some coffee. That's it. That's a lot better. Then these are my ROSject that I have. I have a lot, and as you know, I have a lot about the live classes, of course. Then the one for today is this one, live class number 54. And what I'm going to do is, you see, I have my ROSject. I click on it, and then I click on share. And on share, I'm going to copy the link here. So this is the link to my ROSject, to my code. And I'm going to paste this into the chat of the video, or the YouTube channel. So you can copy, you can click on it, okay? And there it is. So you have there the link. Just press on that link, and then it will generate for you a copy of my ROSject. So you should lead to one similar page to this one. It depends on your ROSject, but you will have this ROSject also. Once you have that, then you click on it and then open the ROSject. Okay, so you open it, and that's it. So it will work. Then let me see some questions here. I see Sevket also has arrived, and Marcus is asking, what kind of controller are you going to build? So we are going to build an effort joint controller that receives position control signal. So a position, a location where the robot has to go, the joint has to go. So that's what we are going to create today. Yes, so I hope that you have everything. Do you understand the steps? It's quite easy, as you can see. In case that you get stuck or you don't understand one of the steps, please use the chat on the video page and ask me questions. I will be reviewing the questions from time to time. And you don't have to wait until the end, because I don't want you to get stuck, okay? I want to follow the same steps as I do. Okay, so you got it. You got this ROSject, then click on it, and then go to open ROSject. Okay, once you open the ROSject, you will have this screen here. This notebook will automatically open for you. Okay, this is a notebook that contains all the material that we are going to do today on the live class. As you can see, we have some code and some images and some instructions. Then, if you close this, you can close this at any point in time. If you close it, by any reason, you can reopen it. How? Very simple. Go to Tools, and then go to Jupyter Notebook. Press there, and then it will show all the notebooks that you have in this ROSject. Remember, this is the specific ROSject, ROS Developers Live-Class 54. So for that, we have this Live-Class 54. Then you click on it, and then it will reopen everything. Okay, I think I have the simulation running. Yes, it's running. So let me close it, because I want to start from fresh, from zero, like in your case. Okay, great. Everybody is there. Then let's see, Rosek has just arrived. And yes, so everybody is there. Okay, let's go. Let's start. Then in this case, so if you remember on the last class, we were working with ROS Control and activating controllers to control the joints of the robot. Yes, so if you remember, we were using this very stupid robot. It's very ugly, but it's quite interesting in order to learn about control and joints, and URDF is very good design for that purpose. So we loaded the controllers for controlling the joints of the robot. And what does it mean? Well, controlling a joint. It means that when you want to put one of the joints at a given position, then you have to have there a program that is receiving your desired position, the position that you want the joint to be, and then this software, this program has to send signals to the joint in order to move the joint towards that position until it reaches your desired position. So that's the control of the joint, and that's what the purpose of the controller. Okay, so here what we are going to do, the most typical type of controller for a joint is a PID controller. Yes, and that's the one that we used on the previous class, a PID controller. And then in this, it could happen that you may want to have a different type of controller. For example, a neural network-based ROS controller for the joint. Then how can you implement this? Also, you may have some controllers with spring effects that you would like to model. So how do you control this inside the ROS control? Well, that's the class that we are going to do today. So how can you create those kind of controllers? Okay, so the requirements for the class of today, it will be, we are going to create now, as an example, an effort-based controller. As somebody, Marcus, I think it was, he asked on the chat. And then we are going to accept position values. So we suppose that the joint is controlled by effort, but the values that we are providing to the joint is a given position. So we want the joint number 3 to go to the pi radians, for example. Okay, so that's a position, because remember that the joint, the positions are angles, and then it's measured in radians. And so we are going to call this, actually is not correct, this is my joint. It's, so I changed this on the last minute. So, but I didn't change the name here in the instruction. So it's I changed it my position controller, exactly. So we are going to call it my position controller. Yeah, so that's how we are going to call it. Then how are we going to do it? Well, so the first thing is that we have to create a package, a ROS package, where we are going to put all the code in there. Then remember, here I have put another figure that I have taken from the web of ROS Control, and it's been created by Dave Coleman. Dave Coleman is one of the creators of the Move It package. Well, actually, he's the main lead developer there. And so he created this image in order to explain better. So here you have all the structure of the connection between a ROS program that will be here and a real robot with a joint, and then how that goes through the controller manager. Then inside the controller manager, we have the controllers, and this yellow box here is the controller. And here is where there is the PID controller loop, for example, for a joint position controller. So basically what we are going to build is this box, this yellow box here, okay? So all the rest, we are going to assume that we are using the standard things. So everything that we created on the previous live class, okay? So don't worry if you were not on the previous live class, everything is included here in the ROSject, okay? So you don't have to do anything from the previous live class in order to follow this. Okay, so let's create our package first. Then for that, we are going to open a shell. Let's go to Tools and then Shell. Okay. So here in the shell, we are going to move into the Catkin workspace, because it's there where we are going to put some control code that is going to be used on the robot. So let me check my connection. Yeah, okay. So I need to change connection. Yeah, because this one is going. It goes properly. Then, yeah, so I have changed the connection, and I hope that you can still see me, and there is no problem. I can see that all the systems are okay and correct, but let me know if you have any problem, okay? Or I'm checking the chat. And I see that Gloria has arrived. Very good, Gloria. Glad to have you here. And also one guy that has his name in Arabic, and I cannot read, sorry for that. This guy, also please click on the link. Adam is sending me feedback and saying it's okay. Thank you, Adam. Thank you very much. Okay, let's continue. Then if you open a shell, a terminal here, and you do an ls, a command of Linux, then you can see that there are several workspaces. One that contains the simulations that we are going to use today is called the simulation workspace. And then there is another one with a notebook workspace that contains all the related stuff for the notebook that you can see here. And there are other more, but today we are going to create a ROS program, and that has to go to the Cat King workspace, as you probably know. Okay, so let's go inside the Cat King workspace and then /src. Remember, every time that you create a package, a ROS package, it has to be on the Cat King workspace /source. There is where we create our packages. There should be nothing, just the CMake list, the main one. Okay, let's create it. So I have put it here, the command, and it's quite a little bit long because it includes several dependencies. Okay, so first, how do we use this command? Let me copy and paste here. And okay, so I have included the initial value of the dollar. Okay, here it is. Then we have the command catking create, and then the name of my package that is going to be called my controller. Okay, you please use the same names as I am indicating here. You can change the name later when you are on your own, but if you change some of the names, then maybe you will be confusing. So you will have some trouble following the example. So, okay, wait, let me reproduce it again. Okay, so we have my controller is the name of my package that is going to be created, and then it depends on ROS CPP because it's a C++ ROS program that we are going to create. Also, it depends on the plugin lib because the controller is going to be treated as a plugin. Then we need, of course, to inherit from controller interfaces and from hardware interface because inherit no, but depends on those packages of ROS. Okay, so that's it. Whenever you have to create, okay, so yeah, let me go to the beginning again and remove the dollar because I copied with the dollar also there. Okay, there it is. My package has been created, and there it is, my controller. You should be there. And what else? So let's start populating the controller with the proper data. And here is the step number 2, where we are going to create all the source code that defines the controller. Okay, so we could use also the terminal to create that source code using a Beam editor, but that's a pain for the non-Beast programmers. You know, I have met so many people there that they are programming in ROS using Beam. And for me, those are Beast programmers, the best of the world. But unfortunately, I have not that level. And many people also that are starting, maybe it's too difficult for them. So let's use an IDE, a graphical tool. For that, let's go to Tools and then use the IDE here. And there it is. We have our IDE that is going to make our lives a little bit simpler or easier. And here we have the different workspaces, as you know here, as you have seen here. So we need to go to the Cat King workspace, open it here. Then we have source, my controller, include, and source. Okay, but everything is empty, just the empty package. So let's create a file here that is going to be called, create a file name, my controller CPP. Yeah. So let's right click and then new file. You can delete that one and call it my underscore controller.cpp. Okay, because it's going to be a CPP file, a program. And remember to use the same names, okay? Otherwise, afterwards, it will not compile, it will not find the library, etc., etc. Okay, so first thing, what do we have to do? Well, we have to include, actually, in C++, it's called include instead of import, all those header files. Well, the main ones are those three ones: one for the controllers interface, another one for the hardware interface, and another one for the plugin. For the plugin, that's the basic structure of any controller. And then we are going to use a standard message of float 64 for receiving goals messages. Okay, so we'll use a float 64 value to receive inside a topic, inside the value of the joint that we want to control. Okay, so that's it. I mean, that has nothing interested in there. Then the next thing that we are going to do is to add a namespace for our controller. And yeah, so these allow us to encapsulate our controller inside our own namespace, so we can avoid collisions of names of controllers in case that we provide a controller the same name as in another case. And well, that's just a matter of that. So you can copy all this and put it there in the code. Okay, you can see that the rest of the code that we are going to add is going to be inside that namespace. Okay, so remember that everything is going to be inside there. So what is the next step? The next step is to create the class of the controller. So yeah, so that's the main class, the one that is going to handle the whole controller. And because of that, well, we have this code here. Let's copy it and paste it here in the middle of the code. And I would like to do some indentation here because so it's easier to understand afterwards. Yes. So here, let me put it here. Yeah, you can see better now. Then, so that's the class. It's my position controller. That is going to be the name of our controller. And then this is a controller class that has to inherit from this controller interface. Okay, so you have to inherit from that class that is a controller interface controller. And then this is a template. Okay, you don't have to understand what is that. Just in case, the only thing that you need to understand here is that you have to copy everything like this for your own controller and then change just this final word. Sorry, I cannot select properly here. What is happening here? So this is the only thing that you should change in case that you would like to generate a different type of controller. We are generating an effort joint controller, but maybe you would like to have a velocity controller or a position controller directly also. So then you would change that. In this case, it's an effort controller. That's why we are inheriting from that controller interface controller of type effort joint interface. Okay, so remember this. What is this class doing? So if we go here to the code, basically what it's doing is this class has to provide first on one side the interface with topics to the ROS programs, so the ROS programs can send to the controller the requested values for the joints, and then on the other side, then it has to communicate with the resources provided by the hardware interface. Okay, so that's the two things that has to have the controller. In one side communicates with the ROS interface and the other communicates with the hardware interface. If you don't know what is a hardware interface, you need to check the previous live class, the number 53. Okay, so that's a goal, okay? Remember that. Okay, so now inside this class of the controller, you have to create some mandatory functions because it's inheriting from this class, from the class controller of type effort joint interface. And for that, in order to the plugin to work properly with the controller manager, you have to provide some functions. Okay, so one is the init that we have here, another one is the update, and then another one is the starting and stopping. Okay, let's go one by one. So the first one is the initialize the controller. This is the function that the controller manager is going to call when it's loading the the controller into the system. Okay, so this is the code here. You can copy all that and put it here inside the bracket of the class. Okay, so remember, we are kind of doing inside of some bracket, inside some other bracket. Yeah, so you can select this cell, select that, click here on it, and then do Control A to select everything, and then Control C to copy. And once you have everything, you can come here and be aware that you have to be between the brackets of the class, okay? Those here, and then you can paste, Control V. Okay, so I have put in the code here with the proper space. So when you paste it here, it appears already indented. So I hope that it's also working for you. You have copied everything like me. Let me check the chat just a second. Let me see if there are some questions. Then here, there Computer says, I'm late, but still here, and save the ROSject link. Yes, very good, there Compute. Nice that you arrived. And then Basan says, hi. Daniel Jeffrey says, why does it not find the controller header file? Oh, yeah, because we haven't included any header file here. This is a very simple controller, otherwise it will take very long. So everything, it's included inside the CPP file. You see that we are defining here the class. We are defining the class from what it inherits. We are defining here the functions. So everything is included inside the CPP. So you don't need to create an extra header file for this class. We are not going to do it here. It's just a matter of going faster, okay? It's just that. And then Vasant says, can you please share part 1 ROSject? I miss it. Oh, yeah, so I'll go later. When we finish, I will share the ROSject here again of the previous live class. No worry. Then it says, I mean, this line include, it says file not found. Where, okay, yeah, maybe you mean, oh, okay. Yeah, I see. Yes, because of the red thing. Yeah, so sorry. This is a problem that we have at present with the autocomplete system and linked system of our editor here that is not properly configured, and then it's indicating those errors. Okay, so we still have to check what is happening there and solve the problem, but at present it's not working properly. So even if it says that it's not finding it, it's fine. It's going to find it when we compile. So don't worry about that. Okay, trust me on this. As you can see, I have also the same problems here. On the clear identify, well, this is because it has not been imported, this one. So don't worry about that. It's not a problem. It's a problem in our side, in the environment, okay? We'll solve in the close terms, in the close time. Okay, so what do we have in the init file? In the init file, what we do, this init file has to have this signature, okay? And this is going to be called by the controller manager when you load the controller, when the controller is loaded. And what do we do here? Well, the initialization part of the controller. In this case, what we are doing is first, we are getting the joint that we want to control. Okay, so the joint that we want to control is going to be specified in a config file that you remember from the previous live class, what we are going to review here today. And so this config file has loaded the name of the joint into parameter that is called joint, with the name of joint. Okay, so what it's doing here is basically getting the param value called joint for that specific joint. Okay, so for that specific joint, it's going to get this parameter. Once you have the name of the joint, then you have to go to the hardware interface, and then say, okay, this joint named by this name that I have get it here, then this joint to which hardware resource it actually is associated. And then we get that hardware resource here. Okay. Then the final thing that we do here is just to get the current position of the joint, we are getting that and we assign as the current command for the joint. That means, hey, controller, check which one is the position of this joint that we want to control, which one it is. Okay, it's 0.7. Okay, then my next command is going to be to put the joint at 0.7. Okay, so that means let's maintain that position until another command arrives. Yeah. Okay, so that's the first thing that we do in the initialization. Second one is the parameter that we are another parameter for our controller. So in this case, we have done a very simple controller that is just it just works as it checks which one is the desired position, which one is the current position. It takes the difference, and then it generates an effort that is a multiplication between the difference, the error, and the gain parameter. That's simple. That's simple. Remember that in the previous live class, we have a PID. So we had to recover here 3 different values, P, I, and D. But in this case, for this case, I'm simplifying for going faster, but you get the idea, okay? So here we are getting the gain parameter of our controller. Finally, we are subscribing to a topic that is going to be called command. Command, it's a topic that we will be listening for orders for that joint. So this command topic is the one that is going to receive the orders from other ROS programs that say, hey, joint, you must go to this position. Okay, so we have to publish here, then this subscriber is listening there, and whenever there is a new command, it's going to activate this callback that is called set command callback. Yeah, there. Okay, so far so good. Yeah, let me check the chat and see if it is going. And RZ just arrived. Hello, and let's go continue. Then what it's else? So as I mentioned here in the controller, we have to create the init function that just initialize, gets the parameters, and gets the topics for publishing the values. And then we have to create the update loop. The update loop is the loop that is actually going to do the control. So in that image here on the top, that would be this part here that we have here in this small square. Yes, in the previous controllers that we used in the previous live class, it was a PID loop. In our case, it's very simple. As I mentioned, this is the one that is going to be called in a loop or continuously by the controller manager. So it's going to call it all the time in a high frequency. So it's what it does is it computes the error, the difference between the last command that we got and the current joint position. So that's what it does. And then this is the error. And then we multiply the error by the gain parameter. You remember, the gain parameter has been obtained here from the file, from the parameters file, configuration file, yes? So we multiply this, and this is the commanded effort that we are going to send to the joint. And then in order to send that command to the joint, we just have to call this function here, set command, and then the command, of course. That's it. And another thing that I have included here is the set command callback. Remember, this callback is the one that we have here every time that somebody writes in the topic command. Oh, sorry. Yeah, there it is. So this is the set command. Yes, here. So that's it. Basically, it receives a callback message from a topic. You know about that. It receives the message, which is a float, and then gets the data of the message. That is the command value that we want, is the position. Okay, we want to get on that robot. Okay, on that joint. So let's go. Let's do the same procedure. Click on the cell, then Control A to select everything, Control C to copy, and then go here. And you should put it after this last So here, yeah, so after the bool init function that has finished, okay, put it there. Yeah, here. Well, actually, if you copy it like that, yeah, it will be auto, the indentation will be properly done. If you do a Control V, okay, so I have already explained the update and the set command. Yes, if you have any question you are not following, let me know, okay? Okay, then finally we have the start and stop functions. So it happens that you can load a controller but not start it. Or you can have a controller that is started and you can stop it using the controller manager. This is something that we haven't seen, and maybe another day we'll see how it works. But basically that's it. So we have to provide those start and stop functions in this controller if we want that the robot, that the joint does something, or the controller does something when somebody starts or stops. In this case, I have created them empty, but I'm putting them here because they are important, that you are aware of them and that you maybe have the chance for your own controller to do some things in there. So let's copy and put it here after the last function. And in this case, yeah, I did wrongly the tabbing, but the indentation, but it's okay. You can modify and put it properly. Okay, then we are about to finish the creation of the controller. And then the next thing that we need to do is to provide some private members of the class, because, well, we need them in order to be able to communicate information between the different functions, yes? And what do we have? Well, first one is the joint that we want to control. And it has to be of this type, hardware interface joint handle. Okay, so, and then that's the joint that we want to get, the joint resource. In ROS control terms, is the joint resource, okay? So then also we have the gain. The gain is remember, is the parameter that we are using. We are loading it from a config file. We are going to see where in a minute. And we are getting this into the init function here. Yes, it's here. It's where we get the parameter gain and we put it inside our class variable gain underscore. Then we have the command. That is, the command is, as I mentioned, is the set point that we want to set our joint. And then the subscriber this subscriber is the one that is listening for commands. Yeah, okay, so let's copy everything here, copy, and then paste it also beneath the last code. And that's it. So if we had, for example, an H file, then we will have a header file. We'll have all this code inside the header file, for example. But we don't need it because it's quite simple. Then finally, before we finish, we have to include this macro. This is a special macro from the plugin lib, that what it does is to register what we are doing in this class as another controller that is available for the controller manager. Okay, so you need to copy this line. Let me copy and paste it here also. But this has to go outside of the class, okay? This is nothing related to the class. I mean, it's not a member of the class. It's a member of the workspace in which we are, of the namespace, sorry, that we are working here. Okay, and basically what it's saying, this plugin is for class, is saying, hey, we have this new controller that is called my position controller. And it's a type of controller interface controller based. So it's related to, it's a plugin for as a controller based type. Basically, that's it. Okay, so if you want to know more about the plugin, it's plugin lib. It's quite a little bit confusing. I have put here a link with that links you to directly to the documentation, official documentation. And here you have the full code. So it has to look for you like this. So if it doesn't, then you have done some mistakes. That is, it's quite likely. I mean, it's quite easy, not likely, sorry. It's quite easy to do it, to commit mistakes here by having the code in several chunks in different things, so it's quite easy. Okay, so we want to compile this controller. We have done it. Let me check if there is any question related to the understanding. And then there is a question here from Ritesh that says, to move a servo motor, do we have to create controllers like this? Maybe a stupid question. No, please, no question is stupid. Just if you have a question, just ask the question. I'm here for that, okay? So, and there's people with different levels, with different backgrounds, so it's normal that some things are not clear. And then you have a question, say it, okay? And then to move a servo motor, exactly, that would be the case. But probably the thing is that you can use, it's very likely that you can use the controllers that are already made by ROS. So if you check the previous live class, then you will see how to use the the already made controllers. This is for special cases, okay? And it's also an opportunity to learn more about how ROS control works in the inside. That is why. Okay, let's continue then. Then we want to compile. Yes, but first a little bit of coffee. Great. So we have it. Then what do we have to do? Well, the next step is we have to create a file that is called the controllers plugin XML file. Okay, this file, it's a file that you can check why we have to create this and the format of this file, a specific format. And here in this documentation that I mentioned here about the plugin lib, okay, there is where it explains. But basically in this point here, you just have to create that and that's all. So this is the file that is indicating to the plugins system that, hey, in this package, there is a plugin. Basically is that. Okay, so let's go and create this file. Let's go here. It has to be created inside the source. It has to be created inside the my controller directory. Okay, so beside the CMake list and the package XML. So go to my controller and then right click new file, and then you have to call it. I don't remember. That is why I put the notes here. Yeah. Controller plugins, controller underscore plugins dot XML. Okay, and then copy this content here of the whole cell. Control C and paste it. Well, this is the format that you have to use. Okay, so if your controller is called my underscore controller, then you have to indicate it here. You have to do first, you have to put lib. You have to put lib/lib. Then the name that you have selected for your controller, and then underscore lib again. So in case that you want to create another controller, you will have to modify here the name. Then what else? Then here the class name. So the class name is my controller, and then the name of the class. Then next thing is the my controller namespace, and then my controller, my position controller again. And then finally you have to indicate that it's the base class from the one that we are inheriting, and that's a controller interface controller base that we already have mentioned before. Okay, so that's in order to indicate that this package contains a library, a plugin. And now we have to modify the package XML in order to be able to take action with this controller plugins XML, so that gets recognized by the ROS packaging system. So for that, remember that inside the my controller package, you have this package.xml file. Open it, it's already done, okay, by the system when we create it. And then you have to go down, And here you have all the built-in dependencies and execution dependencies that this has been automatically created by the system when we created the package. Remember that we specified all those dependencies. Now we have to include here where it says export, a specific line that is directing the package system to that controller's plugin file. Okay, so and the line is just here. Just copy paste, and I mean, not necessary to learn more about that because it's always is like this. And here is the name of your XML file that defines the controller plugins, the one that we have done it before. Okay, so finally, before we can compile, we have to modify the CMake list in order to make it compile a library, because this controller is a library. As a plugin, the end result is going to be a library. So let's open the CMake list here of our package. Remember, it has to be the one of our package, yes? Yes, that's the one, yeah? Okay, so then we have to look for a place that says add library, and usually is below, and it's it should be, let me see, should be here. So it says add library, project name, etc. So that's a template that you can use. I have already put it here, the code that you had to put in the add library. So you can directly copy this and include here. What this is saying is, hey, please, you have to go to the source, my controller CPP, and compile it and generate my controller link. Okay, this is the name of my library that is going to be generated. And then another thing is that the target link libraries. So this is another point that we have to include here. And you can check where it says here in the CMake file where it says target link libraries. And it was a little bit below. Yeah, here it is. Okay. Yeah, so here it is. And you can either modify the one that is here and remove the comments. Okay, you can do this, or you can just copy here the content and then put it there. Okay, so it's the same structure with the spaces and yeah, and sorry, spaces and carriage returns in this case. And yeah, so that's it. By adding those two lines, we are specifying to generate the plugin as a library that can be linked with other systems also. Okay, so now it's time to build the controller. And let me see if there is any question. And then here there is a question that says, why do we not include ROS.h? Because it's already included in any of the other include files. Good question, Daniel. Mohammed says, I am working on a 4-wheel autonomous vehicle. What type of controller should I make to move it? Sorry for the relevant question. No, there is a controller in ROS Control for 4-wheel vehicles that it's called steer, what's the name in English? It's a steer. So I don't remember the name, but it's a steering, no. Well, I don't remember the name, but if you go to ROS Control, you check for the list of available controllers, you are going to see a skid steer, exactly, a skid steer. No, the differential drive controller that Daniel is suggesting, this is for 2 wheels robot. You could also use it for probably in your autonomous robot, but with 4 wheels. But the proper one is the skid steer one. So check for that one and try it. And then Abraham says, it is the same like this class to use fuzzy controller to obstacle avoidance for mobile robots in ROS. Okay, no, wait, you are mixing things here. We are controlling here just joints. We are not doing a control for obstacle avoidance here. That's another thing. Yeah, I see that they say controllers for everything, but in this case, it's a setting a value for a joint. That's it. Okay, let's continue because we are almost there. So if you have followed those steps here, you should be able to compile. Then let's go. Let's open a shell. Actually, we had one here. And let's go. Remember that you have to be inside the Catkin workspace in order to compile, okay? So if you are in source, you have to go up one directory, and then here issue the command catkin make. And then our controller is going to start working. Now is the time where we have to cross our fingers and see if our work has paid enough. And in the meantime, coffee. Okay, so my controller compiled, very good. That's very strange because I usually make mistakes in the middle, even if I copy paste. Yes, I am that good. So, but in this case, I think that all the gods, they were with me today and they make me compile it properly. What about you? No questions there, so I suppose that you are doing it. Then, okay, so we can check first that our controller has been properly registered by typing this command here. And if you type it, then it should appear our controller, oops, it has not. Okay, let me see if I have. Okay. So it doesn't show. Why not? It should be registered and detected. Okay. So it's not showing here on the list. Let me see. Okay, no, it's not showing. Usually appears at the end. So if it doesn't appear here, it's because something is wrong, but it has compiled properly. Let me check if it has created here the devel and the level and the library package. Here it is, the library has been created. Also, we have the controllers plugin here. Did I put into the proper directory? Yeah, I think it's correct. So let me check if I have modified anything in there. My position controller, controller interface. Yeah, so my controller, that's the name of our directory that is called here. And let me see, my controller, I created properly. Yes. My position controller, that is correct. My controller namespace is also correct. Yes. Controller interface, controller base, that's correct. And then finally here, controller interface, then is the controller plugins XML, is correct also. Okay, so I don't understand why it doesn't show. That's strange, and that maybe there is a problem here with our execution. Let me see, let me do a ROS pack profile to see if it is getting the new packages like but in theory it should have already done it. Yeah, it doesn't show, still doesn't show my controller. Okay, so I don't understand why, but let's keep moving forward. Okay, so that was just a check that has been there. Let me see if we can get more information going forward. Okay, so then let's launch the controller. Then remember that we want to apply this controller that we have created to the headband joint of our robot. Yeah. Then for that, if you remember, when we were playing with this simulation last week, we had a file, a config file that was specifying for each type of joint, which type of controller we should load, okay? So let's go to that file and modify this value and indicate, hey, now for the headband joint, you have to use my controller. not the one that was being used, the one provided by ROS. Okay, so how do we find that? For that, we need to go to the simulation. That would be the simulation. I mean, we need to go to the to the URDF of the robot. Then in that case, let's go to the simulations workspace that is here, and then go to source. And here we have the Pi robot. Let me put it this like this. Yeah. So here we have the Pi robot inside the Pi robot package. And then here we have a config file. That's a config file that contains all the parameters for all the joints, for the control of all the joints. Double click on it to open it. And you remember this file, yes? So now what we want is to modify this configuration here. Yeah, this configuration here, because it's a headband joint that we want to change from the FO controller, joint position controller, to my controller. Okay, so let's do it. Change the type by my controller, my position controller. So copy this, come here and modify this. Yep. Okay, so I have included my controller, my position controller. Now the joint is still the headband joint, of course, that's correct. Then PID has no meaning now because we are not using a PID value controller. And here is where we are going to put the gain parameter. Do you remember that I mentioned about the gain, that we were getting this gain value from the parameters here in the controller code? Here is the gain name, yeah? So that is where we should put it in the config file. That is, let me see here. And this PID, you can delete that. And then put the gain 2 dots and then 0.1. I have put this value as a, for example, and I check that it works. Okay. So far, so good. And it's not showing, neither we can see here people say source. Oh yeah, so we have to source, that is right. Yes, I haven't sourced, you haven't sourced that. Very good, everybody's saying yes. Thank you very much, yeah, very much. Okay, so let me see if we source that. Let me check this. So let's do a source of the devel / setup.bash. Is to get all the new stuff that we have created. And let's see now, yes, now the controller appears here. Oh, very good people there. Thank you very much for your help and for the support. Very good. Okay, so we got it there. And this is very important to do the source, okay, because otherwise sometimes don't get recognized, and then the system is not able to find them, and probably we will have had some problems later. So that's very necessary step. Okay, so now we are ready to launch it. Let's go and see the results. So first, we need to launch the simulation. The simulation is already included here, as you can see. Then let's use the ROSDS simulation menu to launch it because it's quite easy. Go to simulation, select launch file, and here select on the menu the main.launch file. By clicking there, a new window will appear where the gazebo simulation is going to load. Okay, so it's starting, and we are going to see in a few seconds how it appears. Now, afterwards, we are going to launch this file that contains the controllers. Okay, so let's open this controllers launch file. This is a launch file that is included inside the Pi robot package. Okay, so this simulation is launching the robot without the controllers yet, just the robot simulation. And now we need to, afterwards, we need to launch the controllers in a separate launch file. I did it this way in order to be more for educational purposes, okay? Usually you will launch everything together. Then here is the controllers launch file. And if you open, you can see that what it's doing, basically loading the robot description, loading the control YAM file with all the configuration, and then spawning all the controllers here. Remember, this is the one that is spawning all the controllers. I have removed the joint state publisher, and I have also removed the RBS that we had on the previous live class. And here we have the robot state publisher, of course, that this is necessary in order to have the transforms, the TF transforms. Okay, so I think that the simulation should appear here already. Yes, there it is, and the robot without any control. Now let's go and launch our controllers here. So, okay, let me put it here so we can see how everything works. How do we launch the controllers? Well, I put the command there. ROS launch PyRobot package, then controllers launch. Then we have to see here, if everything went okay, that all the controllers are getting loaded. And here we have, started controllers, head pan joint position controllers. So it looks like everything went okay. Very good. So, and then the robot is now under control. You can see that the joints are not moving anymore. Now, let's open another shell just to check, okay? So here, shell. And let's see if our topic accepting commands for this joint is available. So let's do a ROS topic list, and then here there should be something like PyRobot head. Here it is, head pan joint position controller. Okay, so here it is, /command. So that is our command topic where we should publish a command for moving the head. Okay? And as you can see, it has a different format than the other head joint position because we have changed the controller. Of course, that's normal. Okay, so let's do it. Let's move it. Let's move let's see if it is accepting commands, and let's see if it's moving actually the robot. And for that, well, I have included here another controller, another command to check in case that you have some errors to see which controllers have been loaded. We are going to skip that because of the time, and then let's go directly to the command. Okay, so you can copy here. The command is here on the bottom, and you can do experiments later. Paste it here, and what does it do? Well, it's a ROS topic pop on the topic that we have created for our joint of the robot. Then the type of message, remember, is a float 64. And then the data, remember, this is the position that we want the robot to achieve, the head. It's 1. Okay, so let me show here the gazebo. So I'm going to launch the command, and we should see the head moving towards that position. And that is, yes, it is moving. It's moving slow because the gain parameter was very small. And I didn't have time to test other values and better controllers, whatever. But you can see here how the whole loop of control has been accomplished and done. Okay, so that's it. So we have achieved that, the goal, that is to get a controller that is accepting commands for a joint and then is actuating over the joint. Okay, very good, very good. So let me show you a homework that I would like you to try. Okay, so your homework is to create a neural network-based controller for the left shoulder forward joint of that robot. So this neural network has to take as input the desired position and the current position of the joint. Then it takes as output the command that is going to be sent to the joint resource, in the same way as we have done it here. And you can use, of course, TensorFlow to build and train the neural network. I have put here a course that can teach you how to do that with ROS. And you can generate training data by using the PID controller that already exists on here. So you can use this in order, and then you will generate a neural network controller that is emulating the current PID controller that is there. Send me your questions, okay? See, if you try that, send me your questions and results, and I'll be happy to review them and help you. And that is all for today. So please, I would like to ask you that you can give us a like in the YouTube channel, a thumbs up, or whatever you call it. And of course, subscribe to our channel, because we are publishing new videos every day about ROS, how to improve your ROS level, how to do this, how to do that. And in that sense, we are doing the second ROS Developers Conference. That's an online conference that our company is doing. It's online, so you don't have to travel anywhere. And in this conference, you are going to learn from the experts. So you're going to practice in the same way as you have done it here in this live class, but for other people around the world. They are experts that are going to come to the conference and give you the class with the notebooks, with the simulations, with the code, and they are going to teach you in a series of 8 talks, a practical ROS project in different subjects. And I have put here a link, also the videos of the previous ROS DevCon, so you can check what to expect by attending. You don't have to travel, you only have to connect in the same way as you are doing here. And if you want more information, it's here. The time for early registration is about to finish in 14 days. And that's it. Let me check if there are any questions there. Let me see. And here it says, Marcus has published a video that I don't know what is that about. And then say, Mohammed says, can't find a skid steer controller anyway. Thank you. Okay. Yes. Let me put it there afterwards on the comments of the video. I will look for that, Mohammed. Okay. And then Abraham says, I want to use a fuzzy control for obstacle avoidance. Do you have any advice? Okay. Not on this on this class, sorry, not now, because it's a different subject. Then link of previous live class project. Yes, I'm going to do it right now. Let me go to my ROSjects here, and here they're live class 53. So I'm going to share with you the link here. Of course, anybody that is here and was not on the class, you can also get it. So let me put it here. This is for you, because, and then Marcus says, let me see. Okay, guys. So let me see. Yes. Okay. So Marcus says, could you indicate what should be done to deploy in addition velocity controller? It will be appreciated if you will be able to make a class if possible, of course. Yeah, no, well, that's very simple. You only have to inherit from, instead of from an effort joint controller, a velocity joint controller. That's simple. And then, well, that's simple. Then afterwards, you have to get the velocity. And well, okay, it's not that simple. Yeah, because it's some fields of the class are different. For example, in this case, we were taking the position field of the joint. But in that case, you will have to take the velocity field of the joint. Okay, so but those small differences, I think that you need to check the class. Velocity joint controller, you check the class, and then you will see all the fields that it has. And that's how you can access to them. And then there is the Junjuan. Oh, Junjuan, so long time that I didn't see you. By the way, Junjuan, I'm going to China next week. Actually, on this Friday, I will be there. I will be giving some tutorials, speeches at conferences, and also meetups in Shanghai, in Shenzhen, and also in Guangzhou. And if you are there, you or anybody else that is around, you are welcome to attend and give me an email or something, and then we can meet there and talk face to face. And then Daniel says, can you make a class on making our own hardware interface? Yes, that is going to be very, very interesting class. And it's very likely that we are going to do that. But next live class is going to be about getting clear the differences between the joint state publisher, the robot state publisher, and the ROS controllers. And what is the difference between the RBS? What is the difference between the simulation and the real robot? These are some concepts that we still don't have clear, and is necessary in order not to make the errors, the mistake that we did on the previous live class. Okay, so we are going to go deeper on that one. And then let me think about the hardware interface, because that's a very interesting point and subject. Okay, Vika says, thank you, Ricardo. My pleasure, Vika. And Marcus says, many thanks. Okay, many thanks, Siddharth. Okay, hey, Daniel. Yeah, you talk. Ginger, no problem. Mohammed, thank you for your great work. Thank you, Mohammed. My pleasure. And Siddharth, are you working on a project or studying things? Oh, yeah. Those are your things. You can keep talking between you. Of course, that's super nice. Okay, so guys, I see that there are no more questions. Then it's time to leave, because as always, I'm getting late in this class. Yeah, that's because I like to talk a lot, and then so at the same time, I like a lot of coffee. Then that's it, everything for today. Guys, see you next week. I will do this live class from China itself, and then I will meet you on the next live class. Until then, keep pushing your ROS learning, okay? Keep pushing, keep pushing. See you guys.